Alright, so we're going to do day 6 notes. We're going to be dividing polynomials with synthetic division. So we're doing synthetic division. We have to remember that this method only works when we're dividing. This method only works when dividing by a binomial that's x plus or minus some number. Okay, you can't have anything in front of the x. Okay, so we're going to divide using synthetic division. So example 1, when we set this up, we draw like this box. Okay, when it's in this form, we have to take the opposite number. So we're going to put a -4 out here. Then in decreasing order of our polynomial, we're going to put our coefficients. So 1, -1, -27, -28. So I bring down my first number, I multiply, I add, I multiply, I add, and we're always adding, I multiply, and I add. This number is always my remainder, and then I go in order from the remainder to the constant. This is my x term, and this is my x squared term. So I end up with x squared minus 5x minus 7. Alright, another one. So again, I put the opposite value out here in decreasing order. Bring down, multiply, add, multiply, add, multiply, add. My remainder, constant x squared. So I get 3x squared minus 16x plus 5. So these have non-zero remainders. Okay, same thing. -5 goes out here. 1, 1, -22, -1. Bring down, multiply, add, multiply, add, multiply, add. So in this one I have an actual remainder, and so I write that as x squared minus 4x minus 2 plus 9 over x plus 5. Okay, this one, I put out a +3, 34, -16, 20, -16. I bring down, I multiply, I add, I multiply, I add, and then I multiply. And then finally I add those together. And I get 818. So then remainder constant x squared. So I get 34x squared plus 86x plus 278 plus 818 over x minus 3. Now we're going to do the one with the missing powers. It's just like when we did the missing powers on the other one. So we have to put in a placeholder. So -8 goes out here. So 1, 0, -49, and 120 because we're missing the x squared term. Okay, so bring down, multiply, add, multiply, add, multiply, and add. And so remainder constant x squared. So x squared minus 8x plus 15. Okay, same thing on this one. 9 is going to go outside. 1, -9, 0, -1, because we're missing the x squared term again. So bring down, multiply, add, multiply, add, multiply, and add. we get our remainder, constant x squared, 9x squared plus 72x plus 648 plus 5831 over x minus 9. Alright, so now we're going to factor a polynomial with division. So this is we're going to use division to factor the polynomial. So suppose you're given a polynomial function and one of its linear factors. You can completely factor a polynomial and then find its known factors. So the cool thing is we can use synthetic division to do this. So you can also use long division if you like that better. So I'm going to divide this. Minus 5, and then 2, and then 8. Put a 4, multiply, add, multiply, add, multiply, add. If it's a linear factor, then you're going to have to get a 0 here. So we know x minus 4 is a factor, okay? And then we're left with 1 x squared minus x minus 2. Now we can just factor that. So this is our first step. And our second step is just to factor this. So we get 2 and 1. So x minus 2, x plus 1. So that means this factors to x minus 4, x plus 1, x minus 2. Okay? Alright. So they want us to use long division. I really don't care. We can use long or synthetic. Synthetic's actually easier. So I'm going to do A first. So 1, 0, negative 37, negative 84. We already know 7 is a factor. So we know this factor form is going to start with x minus 7. So 1, 7, 7, 49, 12, 84, 0. So we're left with x squared plus 7x plus 12. That factors to x plus 5. 3 and 4. X plus 3, x plus 4. So this factors to x plus 3, x plus 4. Alright. So B, we're going to factor this, and we can use synthetic again. So we get 2, negative 3, negative 32, negative 15, 2, negative 6, negative 9, 27, 5, negative 5, positive 15, 0. So we know it factors x plus 3. Now we're finding the other one. So remainder, constant x squared, 2x squared minus 9x minus 5. Borrow payback. Payback are 2. And so I get x minus 5, 2x plus 1. Okay, the remainder theorem that says if a polynomial function is divided by x minus c, then the remainder is actually that value at c. Okay, so we use a synthetic division to do something called synthetic substitution. Okay, so we're going to use a remainder theorem on this one to evaluate f of x at c. So what they're saying is that using synthetic division, I'm going to find the same thing as plugging it in. And my remainder will be that answer. So I bring down my 1, negative 3, 5, negative 15, negative 3, 9, 2, negative 6, negative 20. Here my answer is the remainder. And you always check your answer by plugging it in. Alright. B, sorry, I don't feel like I gave you guys enough room for that one. So 1, 3, 2, 4, 3, 2, negative 3. So 3, 5, 9, 12, 14, and that's going to be 11. So that means f of 1 equals 11. Okay? Now the factor theorem says that given a polynomial function f of x minus c is a factor of f of x if and only if f of c equals 0. Okay, so what they're saying is we're going to determine whether each of these binomials are a linear factor by finding or doing synthetic division. Okay, so first we're going to do 1, 0, negative 31, 30, multiply, add, multiply, add, multiply, add. Okay, so this one is not. Okay, second one. So bring down, multiply, add, multiply, add. So that one is. And our last one here, is negative 6. So bring down, multiply, add, multiply, add. So that one is also 1. Alright, B. I'm going to do B down here. So we got 1, negative 6, negative 17, 78, negative 56. 2, 1, 2, negative 4, negative 8, negative 25, negative 50, negative, alright, no, positive 28, and then a positive 56, so 0. So that one works. Negative 7. So 7 times 13 gives me 91, minus 17 gives me 74, times negative 17 gives me negative 1,258. You can tell this one's just getting too big too fast, so you know that one's not going to work. Last one, negative 4. So doing negative 4, and 40 minus 17 gives me 23 times negative 4, negative 92 plus 78, negative 14 times 4 gives me 56. So that one works. Okay. So now we can use this factor theorem to completely factor given a 0. So now that we've done this, and we kind of did that on the other page, so I think we're going to skip A and B because I did this on the last example with synthetic division. So that's it.